All right, welcome back to 105. Thank you for joining me on today's cold evening. So today we get to talk about math and random numbers. So by the end of this lecture, you will definitely have everything you know to complete Lab 1 and to complete a bunch of Lab 2. So let's get into it. So C comes with the standard C library, and it also comes with a math library. So we've seen a little bit of math so far, basic arithmetic, adding, subtracting, multiplying, dividing, getting the remainder sometimes. But if we want to do anything more advanced in arithmetic, we need to use this library. So to add all function prototypes from the library to our code, which is a new word for us today, we need to do like a hashtag include and then math.h on a new line, and that's before creating the main function like we had with our other library includes. So function prototype, new word today. So a function prototype tells you about the inputs and outputs of a function. You might hear the word function declaration, almost the same thing. For the purposes of this course, we can consider it the same thing. Don't worry about the difference. So a function prototype tells you the input and output types to the function. So all function prototypes have this form. So the output type comes first. So you would see that this kind of looks like main. Main starts with int, and that is the output of main. So in general, we can have different output types. We can create functions that output different things. So first thing is the output type. Then the function name comes next. In this case, we've only really seen main. And then there is a parenthesis, and then there are input types here. So you're allowed to have more than one input. We've already seen that with printf. So printf will take more than one input, and so will scanf. Void is that special type that means nothing. So we can have multiple input types. We just separate them by commas. And input types can be void, and that just means there are no inputs to this function, and that is exactly what we have with main. So some examples of function prototypes are, I'll just start adding comments to the code so that everything is all together. So if I have something that says double foo and then brackets double, and then every line ends with a semicolon, that means that I'm declaring that there is a function called foo that takes a single double as input and then outputs a double. So everyone okay with that? Function, one input, double, output, double. If I have something that looks like this, I have double foo, double comma double, well, that means the function is called foo. It takes two doubles as inputs, or there's two double arguments if you want to say it like that, and it outputs a double. Could also have void foo double. So that means there's a function called foo, takes a single double as an input, has no output. And finally, I could have something like this. Again, another function called foo. This time, it goes double foo void. That means it has no inputs and then outputs a double. So any questions about those function prototypes? All right, we are good. So this is how you will read what's in a library. Yep.
Is there like a significant difference between like saying void as a parameter list or just a negative one, just a negative void when they left?
Oh, so yeah, there's a question. So in the last case, do I have to say void or can I just type nothing? So depending on the version of C you use, you can type nothing. The strictest sense of C wants you to type void there. So sometimes it's up to you. You should just get into the habit of just doing whatever C tells us to do. So that's the safest one. Sometimes you can get rid of it. So you might see function prototypes that can actually optionally name the arguments if you want, but these names are only for your benefit to make it easier to read. So example, I could have double foo and then double x and then double y. So those kind of look like variable names, but they're just there to help you understand which arguments are which. You might be confused. If you see a function that takes like 3 doubles, that does something, you might write the order is important, which one is which. So in order for you to understand which is which, you can optionally name them, and then from the name, you know which one to use for what. So the order matters for all of whenever we use functions. So when you actually use this function, those names don't matter, right? I don't have to have a variable called x. I don't have to have a variable called y. They don't have to match whatever is in that function prototype. So just to demonstrate that, I could just say when I use this function, I could just call it with like, 7.0 or something like that. And if I have something like 7.0, like just an actual number that's a value, the compiler calls those literal. So it's like a literal number. Yep.
If I don't name my arguments, right, then how can I, like let's say I have like double and then double.
Yep.
And arguments, how can I refer to like each particular one of them?
Yeah, so these like having no name, oops, like here, just foo double double. So if you were to write this function, right, you would have to name them. But in this case, this is only to say what arguments the function takes. That's the only purpose for this. But when we get into writing functions, yeah, we'll have to name them. But we're not writing functions yet. That's later in the course. All right, any other questions? We're good. All right, so here's some background knowledge because, all right, first off, this little symbol here, what do you want me to call that? Most people probably your age, hashtag, is that a thing? Hashtag, pound, hash, any preferences? I don't really care what I call it. Hashtag, sure. All right, so there's something called a C preprocessor that's part of the compiler that runs before the compiler actually converts what you wrote into machine code. So this is not testable, so this is just to help you understand what's happening. We won't ever ask you a question about it. Other sections probably don't even go over this. So basically how to interpret that is anything that starts with like a hashtag, it's technically called a preprocessor directive. So that's to tell the preprocessor to do something. So that include preprocessor directive, by the time it actually compiles, it replaces that include with the contents of that file. So there's a file somewhere. In this case, that would be called like math.h or std.io.h or something like that. That would actually be a file on your machine. And whenever the compiler runs, it will find that file and just replace that hashtag include with the contents of that file. So those files, you might have noticed so far, they've all ended in .h. It's because they are called header files. Don't ask me why we call them header files, because they're supposed to be at the top or the head of your program. So that's why we call them header files, I guess. Basically, all those header files do is define a bunch of function prototypes in them. So the library will come with one or more header files that contains all the function prototypes that you can use in that library. So we can see what we can use in the math library today. So for instance, there's a function to actually compute the square root. So in math, we'd write, square root of x. We can't just write squiggly lines in C. We have to just use things on our keyboard. So in C, we need to use a function, and it's called, you'll notice this in computing, we like having short forms of stuff, so it's not called square root. We tried to make it as short as possible, so it's called squat. So don't ask me why. Just to save a few keystrokes, I guess. And it takes a double. So in this case, you could call it an x just to match that, so it makes sense. And then it returns a double. So for example, if I called squart with 4.0, well, it takes the square root of 4. Square root of 4 is 2. So you would get the value 2 back out of it whenever you use it. So questions about that? All right, that's the last thing you finally need for Lab 1, Part 3. Now you can do all of Lab 1. So you should be good now. So from this point, you should be able to complete labs sooner than this. We had the start of the course, so that's why. So here's an example in code if I was using square root and I have all of my includes at the top. So I have math.h, that's where that squirt is, the square root function is. Then I have standard IO for printf. Then I have standard lib for that exit success value there. So I just don't have a magic value. If I didn't want to have exit success and just put 0 there, I wouldn't need that one. But exit success, it's part of this header file. So in main, I could have, double y equals 4.0. Then I could create a new variable called this, y square root, and then assign it the value I get from that function. And then if I go ahead and print it with just one decimal point, if I run this, I should see what I saw in the previous slide. And square root of 4.0 equals 2.0. So any questions about that? Pretty good so far. So here is some of the extra stuff. So if we wanted to, we could create our own header file. So for example, one of the things in that math.h header file, it's going to contain something that looks exactly like this. It's going to contain the function prototype for square root. So it's going to be like double square root, double x. It may or may not have the x there, depending on how nice they are. And when I use it in my program, I could actually just do this. If I create a file called square root.h, so I'd create a header file, I could instead include the header file that I created. And you might notice here I have double quotes here instead of those angled brackets. So it has a slightly different meaning. So if you have angled brackets, the compiler will search for that file in the standard library places. If you just have a double quote there, it will search for it in all the standard places and also in the current directory. So you could create this and it can actually go ahead and use it if you want. So I could have my main exactly the same as before. And then before compilation, what the preprocessor is going to do is replace that hashtag include. So in this case, if all my square root.h file contains is this function prototype, after that preprocessor runs and it gets rid of all the hashtags, to the compiler, it will see this as its code. So it will see the function prototype for square root, and then my main that actually uses it. And here is that note, if you want it, that tells you the difference between the file name being in the angled brackets. That's just the compiler to look for the file in the default directories, while if it's double quotes, looks for the file in the same directory as the code. This probably is not testable. This is just to help you kind of understand what the compiler is actually doing and trying to get rid of any magic it has that hashtag include. It's kind of confusing for a lot of people, but really all it's doing, those files just have a bunch of function prototypes in them, so you don't have to type it out yourself or remember what arguments each function takes. They all do it for you. So any quick questions about that? All right, perfect. So there are more and more functions. So there's a function for exponents. So in math, I write x to the power of y. And in C, well, of course, we need to use a function. So there's a function called pow, short for power, I guess. Again, we just shorten stuff for the hell of it. So it takes two doubles, an x and a y, in that order. So that order corresponds to this. So your base is x, and then your exponent is y. And for example, if I used it, so pow 2, 8 is 2 to the power of 8, which should be 256. Questions about that? All right, we're good. So there's trigonomic functions as well. So we can use sine, and sine is defined, cosine, and it has all of those. They're defined in radians. So in that math.h file, there's also the value of pi in there. So to use it, you just type m underscore pi. So whenever you type m underscore pi, the compiler will go ahead and replace that with the actual value of pi. And the value they use for pi is 21 digits long, which is more precise than a double. But unlike, numbers not being able to fit when we had integers, if you have more digits than can actually be represented by a double, it just kind of removes the extra precision, tries to be as precise as possible, and doesn't have all the weird surprises when we have integers. When we had something too big, it just turned into a giant negative number. That stuff doesn't happen with floats, so you don't have to worry about it. It behaves a bit better. It tries its best to represent the number. So here's an example if I use that. So remember, pi is like 180 degrees. So if I want to get the sine of 90 degrees, I just take pi and then divide it by 2. So that's 90 degrees in radians. So sine of 90 degrees, or pi divided by 2, if you're in radians, is just 1.0, so it works. And you'll probably need to use this for lab 2. So there's also logarithmic functions. So in math, usually we write, so you've probably seen like the ln, so like the natural log, or log to the base e. So in C, there is a function called log, but annoyingly, that is not the log we all know and love, the base 10 one. They define log as the natural logarithm, so to the base e. So if I use their log function, it corresponds to what we interpret as the natural log, or the ln, or whatever the hell we call that thing. I forget, I haven't taken math in a while. So if you need the value of e for some reason, you can access it the same way you can access the value of pi. It's just m underscore e. And if I want the actual log, so like in math, when we write normal logs, like normal human beings, or log to the base 10, in C, it's just called log 10. So that's the common, they call it the common logarithm. So if you want to use a log base 10, you have to use that one. There's also a base 2 version if you want to use that. But C has all the common math things we would need. So we can still get a remainder as well using double values. So remember, we can't use that percent operator that gave us the remainder of an integer division because, well, those need 2 integers. So if we want to get the remainder using double values, we have to use a function. So in that case, they named it f mod. So f mod takes 2 doubles, and it gives you the remainder of x divided by y, or the first argument divided by the second argument. So it'll give you the remainder as a double. So if we did f mod 3.5 divided by 2, our remainder would be 1.5. Nothing terribly special here. Other fun functions, we can get the minimum and the maximum of 2 values. This might be useful to you as well. So if I have, there's f min, so that will take 2 numbers, a and a b. Order doesn't really matter because it will always give you output the smallest of those 2 numbers. And then there's also an f max that will always output the larger of the 2 numbers. So if you need to figure out between 2 numbers which is larger and which is smaller, that's the easy way to do it. So might not be terribly useful if both integers are just literal values. So if you ask it, what's the min of 1 and 2, probably a weird thing. You should probably just write 1 because you can figure that out. But usually these arguments are going to be variables. But just to see what we would get, so f min of like 2.0 and 3.5, well, that's 2. Doesn't matter what the order of the arguments are. And then same for max. If I use the same 2 numbers in any order, the maximum of it would be 3.5. Again, any questions? Nothing terribly exciting so far, right? All right, that's good if it's boring so far. So this is where we get into rounding, which gets really kind of weird. So there are several different ways a lot of different ways actually to round floats that all do slightly different things. So there is a function called round, and all of the rounding will always round to the nearest integer, so something 0.0, and there are different rules for different functions. So for example, the round function, it will always round away from 0 if in halfway cases. So if I have 1.5, it'll round up to 2. If I have 2.5, it'll round up to 3. And the next one, rint, computes the nearest integer, and its rule is like the scientific rounding to try and even out the bias. It will always round towards the even number in halfway cases. So if I round 1.5, that rounds up to 2. If I round 2.5, that rounds down to 2 because that's the nearest even value. And I have a little asterisk here. That rounding rule is by default. We won't tell you how to actually change that, so it'll be true, but know that there are also a lot of different rounding rules that all do slightly different things, which is fairly annoying. But these are the only two we have to know for this course. In fact, I think we just use this one for this course, the one that always rounds towards even. So here's, for example, to show the difference. So round 1.5, it always rounds away from 0, so it will always round up. Or in this case, if it was like a negative 1.5, it would round away from 0 to negative 2. So if I have 2.5, again, the rounds up, 3.0. If I do rint, so I round to the nearest integer, the default rule is to round to the nearest even number. So 1.5 rounds to 2, 2.5 rounds to 2. Any questions about that? All right, just kind of something you have to know because, well, that's how it works. So just as a note here, I think I mentioned it before, but I will mention again to be super explicit that using that double format specifier does not change the actual value. So if I have a program like this, so I create a variable called a and give it the value 2.0, if I do a format specifier where I say, hey, just don't print anything after the decimal point, so I can do 0.0 and then LF for a double. If I actually run this, that will print 2.0. So it rounded it. It obviously used the rint because it rounded to the nearest even number. Because I didn't get 3, I got 2. But this format specifier does not actually change the value of a. So even after this printf is done, a is still equal to 2.5. So it will only round it for displaying using that format specifier. If you actually want to change the actual value to be the rounded value, then we would need to reassign a with the result of like rint or something like that. And then for this, if I am just printing off one decimal point, well, in this case, it doesn't even need to round, and it will just always print 2.5 in this case. So, any questions about that? So, format specifier, show you a rounded value, but it won't actually change the value itself. And you can, for this 0.1, you can just use that for the lab. You don't have to worry about actually trying to round the value itself, at least for lab 1. So, if I need to move, if I want to like round more precisely or round a specific decimal point, well, I need to move the decimal point for actually rounding. So if I look at the default rules, they're a bit weird if it's not rounding to the nearest integer. So if I tell it to just print one decimal point after the 0, or sorry, if I just tell it to print one decimal point and my number is 2.55, it always just rounds down. You have no control over it. So if I ran this printf, it would print off 2.5. Like it just rounded it down. It didn't follow any rules or anything like that. It just rounded down. It should have, the rules we had so far, it either always rounded up or it rounded to the nearest even. Following any of those rules, this 0.5 should actually be like round up to 0.6, right? If it followed any logical rules. But for anything that is not an integer, the printf function specifier just rounds down. And to show it, I can do the same thing with 2.65 and that will print 2.6. It just always rounds down. So if I want to actually round that decimal point, we should round numbers, I actually need to shift the decimal point before I actually round it. So I would have to, since all the rules apply just to integers, if I want to just round to 1 decimal point, I need to move that decimal point 1 over to the right before I actually round it. So in this case, I can move that decimal point 1 over to the right by just multiplying that value by 10. So if I take 2.55, multiply it by 10, then I get 25.5, and then I can round that value. So if I round that value and I use it to rint, what does 25.5 round to? 26, right? So that does the proper rounding. Now, if I want to get the original value I have, I just take that rounded value and then just go ahead and divide it by 10 again. So this is what I can do. So I can just take 2.65, times it by 10. So then now when I'm doing that rint, I'm rounding to the nearest integer, and I put the decimal point exactly where I wanted it to. And then after I rounded it, I can just restore where the decimal point was originally by just dividing again by the same number. So now if I do this, it will print 2.6. So it will actually round to the next even number because I'm using rint. And then for this one, well, if I multiply 2.55 times 10, that's 25.5, goes up to 26. Move the decimal point over, and it would print 2.6. So the question in the Discord is, I'll have to check that, but both of those printfs should round down. But if they don't, I will check it after the lecture. So questions about this. So if you want to control the rounding, you just have to move the decimal point yourself. Kind of annoying because all the round functions, they only go to the nearest integer. All right, so there's even more ways to round to the nearest integer if you want to call it rounding. So in math, has everyone have seen like the ceiling operator before? Yeah, okay, so we've seen that. So we can't just use those weird characters. So in C, again, it's a function. Why would we ever call it ceiling? We just call it ceil. What ceil does is it will compute the first integer larger or equal to x. And if I want to do the opposite of that, so called floor, they actually type floor instead of something else stupid, so that's good. So floor will compute the first nearest integer that is smaller or equal to x. So gets a bit fun once we get into negative values. You'll have to realize that, oh, what's larger and what is smaller? So the ceiling 1.1, well, that goes all the way up to 2. Ceiling of 2, it's already an integer, so it wouldn't change. It would just be 2. Ceiling of negative 1.9, well, it goes to the next largest number, so it wouldn't be negative 2 because negative 2 is smaller than negative 1. So the largest closest integer to this is just negative 1. So be careful if you do this with negative values. So same deal with floor. So if I floor 1.9, that goes all the way down to 0. Kind of looks like truncation a little bit if we remember truncation. And if I floor 2, well, it's already an integer, so it stays the same. If I floor 1.1, well, it goes to the next lowest again. So it's either negative 2 or negative 1. In this case, it's a floor, so negative 2 is smaller than negative 1, so it would be negative 2. Questions about that? Perfect. So truncation kind of look like it's similar to floor and ceiling. So when we truncate an integer, remember, we just chopped off the decimal point and we didn't really care past that. So truncate actually happens to be the exact same as floor for positive values, and then the exact same as ceiling for negative values. So That's what happens when you just chop off the integer. So I set it up so the previous slide has all the exact same numbers. So if we truncate 1.1, we get 1. If we truncate 2.0, well, it stays the same. It would be 2. Truncate 1.9, so we just chop off the 0.9, negative 1. Truncate 1.9, chop it off, it's 1. Truncate 2, stays 2 again. Truncate negative 1.1, then we just get negative 1 because it just chops off anything after the decimal. So questions about that? Perfect. So way more math functions available. So there's an entire list on Wikipedia that's clickable if there's a math function you need to find. For this course, you should only use the functions that just have doubles for all the arguments. So we're only considering doubles. That's the most precise thing we have. Just gets rid of a lot of problems. For some reason, if you ever type float, realize don't do that because you'll probably get into you'll run into some very confusing problems that comes with mixing floats and doubles, and weird things might happen. So if you need a number that needs a decimal point, just always use float. And for lab 2, you might find this FABS, that is the function to find the absolute value of a float, useful for lab 2. So lab 2, you should use that function. But just takes a single argument and returns a double, just the absolute value. All right, so we can do a little bit of a problem now. So we can make some change using nickels. So first, actual real problem. So, right, we eliminated the penny. So you might get a total that is in dollars and cents. But if you need to make change, well, pennies don't exist anymore. You can only actually give back nickels. So you have to round to the nearest nickels. So we can actually write a program for that. So let me switch over real quick. Oops. So if we want to problem solve that, a lot of actually thinking about the problem is thinking about what inputs you have and what outputs you should get. So we're just going to have the user enter an amount in dollars. We'll assume it's valid, so they'll just use 2 decimal places and not be mean to us or anything like that. So if I want to round to the nearest nickels, I should think of what my input is going to be and what my output is going to be. So my input is going to be some dollar amount. So someone just give me any old dollar amount that we want to round to the nearest nickel. $42.42. So if that is my input, then I have to think about what my output would be. So if I'm rounding to the nearest nickel, what should the result of that be? So yeah, in this case, if it's $42.42, then my output should be $42.40, right? So that would be the nearest nickel. So what about if I had, $42.43? What should my answer be? So should it be $42.40? No? I should round up? So I should round up. So this problem, if I'm trying to solve it, seems like rounding is my answer. So if I want to round to that amount to the nearest nickel, what probably should I do to solve this problem? Yep.
Could you multiply the dollar amount by 20 to get the number of nickels?
Multiply it by 20 to get the number of nickels? I could do that, but that's might be a little hard to read. Why exactly 20?
Because there's 20 nickels in a dollar.
So there's 20 nickels in a dollar, so I could do something like that. But is there any way where I could just get the amount of nickels directly by just dividing by a number? I guess it's the same thing. So if I wanted to get the number of nickels, I guess the same thing I do, but using the nickel amount is I just could take like 4242 and then divide it by the value of a nickel, right? So if I just divide it by the value of nickel, that will tell me how many nickels I have. And in this case, it will give me some value like, I don't know, some number I can't think of right now, and then probably like 0.4, right? So it will essentially be 2 out of 5 nickels. So the remainder will be 0.4. If I do the other case where I have this, my decimal point is going to be something 0.6 of a nickel. So if I take this and I round it to the nearest integer, well, this one will round down, this one will round up, so that gets me to the nearest nickel, and then it's like the same thing as just changing the value. So I could just divide it by the value of a nickel, get the number of nickels, then round that to the nearest integer, and then just multiply by the value of a nickel again to actually get the rounded value now. So I could do something like printf nearest. So I'll print off 2 decimal places just in case, but just to make it look pretty. But I could take that amount and then divide it by 0.05. So this is the number of nickels I have. And then if I want to get to the nearest nickel, I have to round that. So my rounding function is going to be rint. So that will get me to the nearest number of nickels. And then if I want to restore or get close to the original value again, all I have to do is multiply by the number of nickels again, or by the value of a nickel again. So if I go ahead and compile that and then run it, what's it called, nickels? So I can try it with the amount that I set aside at the beginning. So 4204, I argued that it should actually come out to 4240, which, hey, it does. So this seems to round to the nearest nickel. Just to make sure, we can test it with another value. And let's put a $sign there so it looks a bit better. So if I had 4243, then the nearest nickel is 4245. So it seems to work. So this is the type of code that would be in the cash registers that tell you, oh, how much change they should give you. So they'd have to round it to the nearest nickel and then figure out your change based off that by just subtracting it. So questions about that? Usually when you problem solve this, generally it's easier just to think of inputs and what the outputs should be. Think about how you would get from the input to the output, and then after you come up with some solution, try it out to make sure that you've done it, and we'll get a bunch more practice on this as we go through the course. So that was our problem interlude. So now we can talk about random numbers to finish this off. So there is a C standard library function called rand. Again, why would we call it random or anything like that? Let's just only use 4 letters if possible and call it rand. That function prototype is in standard lib.h. And the function prototype looks like this. It is int, rand, and then void. So it takes no arguments, and it gives us an int. And that int should be, if the name actually means anything, it should just be a random integer. So it will return a number between 0 and rand max. In most cases, rand max will be that very large number that looks a little bit familiar. That is the maximum size of an int, which is 2 to the 32 minus 1. So if you want to double check that, you are free to do that. But that's just the maximum value of an int. So it will return a positive value, 0, all the way up to the maximum positive value of an int. So rand, it's not actually random. It's something called a pseudo-random number generator. Pseudo is just a word for meaning not genuine. It's fake. it's not actually real. So rand uses some mathematical formula to generate the next quote-unquote random number. It's not actually random. It uses a seed value, and it creates a deterministic sequence of numbers whenever you call rand. Deterministic is just another fancy word that we're introduced to in this course. That just means it is the exact same every single time. So if we want to get a different sequence of random numbers, you can change the seed value for rand using, well, something they cleverly named srand. So the function signature for srand is void, so it gives no output, and then it takes an unsigned int seed as an argument, and that unsigned is a new thing. I think this should be the first time we have seen it so far. So the type unsigned int, that goes back way at the beginning when we talked about whole numbers and what whole numbers we could represent just using amount of bits. So if we have unsigned int, it means it doesn't have that sign bit. So that sign bit isn't there anymore, and it can only represent whole numbers. So only 0 up to a big positive value. So if it doesn't have a sign bit and still uses 4 bytes, that means an unsigned bit can represent the numbers 0 all the way up to 2 to the 32 minus 1. So it can't represent any negative values, so it can represent more positive values. So in this course, we just tell you to always use int, even if you know the number can't be negative, because generally it is a bad idea whenever you have to mix signed and unsigned, and it just causes a lot of problems. Like Google had a real famous bug with it where they mix them up together, and then suddenly, I forget what happened. I think they probably lost like $1 billion or something like that. So just don't do that for this course. We're always going to use int if we don't need a decimal. If we need a decimal, what type are we going to use? A double, right? So double, use a decimal. If you don't need a decimal, use an int. If you need to represent something you can type on your keyboard, use a char. And if you need to represent, a 1 or a 0 or true and false, use a Boolean. Past that, we don't have to use anything else other than those 4 types yet. So what we can do with rand is remember that modulo operator. So we can actually use that to generate random numbers in any range we want. So remember, gives us the remainder after doing an integer division, and rand, well, it returns an integer. In fact, it's always positive, so it's a whole number. So remember those weird rules when we had mod with negative values, where the mod would sometimes be negative, sometimes be positive? Well, in this case, since rand only returns positive numbers, well, we don't have to worry about those rules. The result of the mod will always be 0 or above. So if we do something like rand mod 10, no matter what random number it gives to us, the result of modding whatever random number by 10, it's always going to be a number between 0 and 9 inclusive, right? So those are the only choices of remainders we have. So if we want to generate a random number between 1 and 10, well, we can just take rand mod 10. That will give us always a number between 0 and 9. So we just take that result and then add 1 to it. So in that case, we'll always get a number between 1 and 10. So you can use mod and adding to get any range of random numbers you want. So like I said, rand mod 10 plus 1, that means we'll get a random number between 1 and 10. So questions about that? Cool. All right, so if we want to generalize this a bit, if we want to generate a random number between A and B inclusively, where A is less than B, we can use this formula. So we do rand and then mod B minus A plus 1 because we want to generate another number, and then plus a. So we can check that whenever we wanted to do between 1 and 10. Well, a was 1, and then b was 10, so that would make sense. So 10 minus 1, that's 9, plus 1, so that means we would mod it by 10, and then plus a, well, that was just 1, so we get the same result. So this is that general form of getting a random number between a value. So if we wanted to generate, I don't know, a random number between 1 and 6, what would we do? Yep.
Have 1 as A and B as 6.
Yeah, so A would be 1, B would be 6, so what would the actual C result be?
6 minus 1 plus 1 plus
Yeah, 6 minus 1 plus 1 plus 1, so at the end we would get rand and then mod 6 plus 1, and then that would give us a random number between 1 and 6. So any questions at all from today? We got a whole 4 minutes. So should be good for lab 1. Encourage you to do that. Or anything else, I'll be here for a few minutes if there's any other questions, but it seems to be good so far. So just remember, I'm pulling for you. We're all in this together.